chapter 13. So the first thing we're going to talk about is we're going to look at this shape. All right? This shape, as we know, it's a rectangle, right? It's a rectangle, okay? So if we look at this shape, we know it is a symmetric figure. What does that mean, symmetric figure? We also know that it has symmetry. What does symmetry mean? What does symmetrical mean? Well, what it means is that there is a line of symmetry, right? You see the line right there? And if I fold the shape, we can see that both sides are exactly the same. This side is the same as this side. This whole shape is symmetrical. It has symmetry. When I fold it over, you can't see the other side at all because they are exactly the same. The two sides are exactly the same. That is known as, when the two sides are exactly the same, the sides are called congruent. So this is a congruent side, and this is a congruent side. They are exactly the same. Symmetrical figures have congruent sides. So then here's the question. This is the same shape. This is the shape I showed you at the beginning. And if this is a line, we want to see if it's a line of symmetry. Let's fold it in half, fold it on the line, and are those sides congruent? No, they are not the same. So the sides are not congruent. This is not a line of symmetry because it does not make congruent sides. How about this shape? Do you think this shape is a symmetrical figure? Where would the line of symmetry be? Let's try, if we fold it this way, it doesn't work because the sides are not exactly the same. The sides are not congruent. This is not a symmetrical shape, not a symmetrical figure. Is this a symmetrical figure? Well, let's see. If we fold it this way, we can see that it is not, this is not a line of symmetry. This line is not a line of symmetry because the two sides are not congruent. They are not the same. But if we fold it right there, the two sides are the same. They are congruent. So this is a line of symmetry, and this is a symmetrical figure. Let's go back to this rectangle. We saw that one line of symmetry is right there. We fold it in half. We have congruent sides. Are there other lines of symmetry? Can we fold the two corners together? No, that's not a line of symmetry. The two sides are not congruent. But we could fold the different sides together. So this is our line of symmetry. So we see that there is one line of symmetry down the long middle and another line of symmetry down the short middle. So this is a symmetrical shape that has two lines of symmetry. Now let's talk about rotational symmetry. Remember this idea of turns when we were talking about angles, right? So 90 degrees is a quarter turn, 180 degrees is a half turn, 270 is 3/4 turn, and a full turn is 360 degrees. Rotational symmetry, just like regular symmetry, is looking for a figure that is the same. Except for, instead of folding the figure on a line of symmetry, we're going to turn it, rotate it around a center of rotation. Rotate is the same as turning. Okay? So here is a square. You can see that it has 4 right angles. All of the sides are the same. I colored in one of the right angles black so we can watch as we turn. What I'm going to do is I'm going to put it inside my rotational symmetry checker. So if the figure does have rotational symmetry, then when we turn it, around the center of rotation, then we should be able to see it. We should not be able to see the outline anymore. So here, it does not have rotational symmetry. But here, we can see that it does have rotational symmetry because it is inside the square outline again. And you see the black corner has moved. It has moved 1/4 turn. We can continue rotating it, and we come back again to when it fits inside the outline of the square we had made earlier. And you can see that the black square started here, and it went 1, 2, 3/4 of a turn. So this is rotational symmetry. This figure fits inside the outline of the same figure. It looks the same. If we make another key, right? Here's another shape. It's a rectangle. Can we turn it so that it has rotational symmetry? Let's try a corner turn. No, it does not have rotational symmetry at a 1/4 turn because it does not fit inside the outline that I made of the shape. If we start again at the beginning and we turn it 1/2 turn, does it have rotational symmetry? Yes, it fits back inside the box that we drew for it. So a rectangle has rotational symmetry at a 1/2 turn. How about this shape? Remember this shape, right? We're going to turn it around that center of rotation. Trace the outline, okay? This is shape, it's the same as this shape. So when we start, it fits inside the box. We rotated it around the center of rotation. Never fits back in the box until we get back to the original position, right? There's only one way that the shape fits inside the box, so it does not have rotational symmetry. I want you to notice the direction that I turned these figures. When I turned the figures, I always turned it this way, right? The movement around like this. If you notice on a clock, which way does the clock move? The second hand, if you can see, is moving that way, right? It's moving in the direction of this arrow. So that is called clockwise. This direction, the direction of the clock, is clockwise. And if it's rotating in the other direction, following this arrow, it's counterclockwise. So we can describe rotational symmetry. We can rotate it 1/2 turn clockwise, and that's the same distance, and that's the same turning or rotating in the same direction the clock hands move. Counterclockwise is in the opposite direction that the clock hands move. Counterclockwise, clockwise.